Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on rules and formulae. Note, formulae is just the plural of formula. You probably have a common sense idea of what we mean by a rule or a formula, but in mathematics we have a specific definition. So firstly, to be a rule or formula, it must be an equation. Secondly, it must have two or more variables. Remember, that's just pronumerals or letters. And thirdly, one of those pronumerals has to be the subject of the equation. So something like this, y equals 3x plus 4, that is a rule or formula. So it's an equation because it has the equal sign here. It has two or more variables, so we've got y, that's one variable or pronumeral, and x is a second one. So that's really simple. So you probably don't know what I mean by subject of the equation. Subject of the equation means something by itself. So here, y is the subject. Y is the subject because you can see it's over here by itself on one side of the equation. So that's why this constitutes a rule or formula. So something like this, xy equals 5, does that constitute a rule or formula? Well, it's definitely an equation because we have the equal sign here. It has two variables. It has x and y, but neither x nor y is the subject of the equation because we don't have x or y by itself. We don't have x equals blah, 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 or y equals blah, blah, blah. So this is not a rule or formula because neither variable is the subject of the equation. So equations you've been solving like 2x plus 1 equals 7. That is not a rule or formula. The reason is, even though it's an equation, it only has one variable x, so it can't be a rule or formula. Also, x is not the subject of the equation. So another example of a rule or formula, let's say we have F equals ma. This is a rule used a lot in physics. Force equals mass times acceleration. So this is definitely an equation. We see that because we have our equal sign here. We have 1 F, 2 M, 3A. We have three variables or pronumerals, so that's two or more. But here f is the subject of the equation. F is by itself, it's in the form f equals blah blah blah, so we have f is the subject, and thus this does constitute a rule or formula. So what we need to be able to do with rule or formula, we need to be able to substitute and solve to find the value of one of the unknown variables. So let's look at some examples of that. Please pause and copy this down if you need. So here I've given you the formula y equals 3x plus 6. It is a formula because it has an equal sign, it has two variables, and one of them, y, is the subject of the equation. So I'm asking you to tell me the value of y when x equals 4. Now this is easy because y is the subject. It's easy to find whatever is the subject of the equation because all I need is a simple substitution. I'm just going to substitute x for 4. So I take my formula, y equals 3x plus 6, and I'm going to change x to 4. So remember, 3x means 3 times x. So if x is 4, it's 3 times 4. So y is just 3 times 4. 12 plus 6 is 18. How easy is that? Now, it's a little more difficult when we have to find something that's not the subject. So now I'm going to ask you to find the value of x when y equals, let's say, 30. So this is a little harder because I have to actually use the process of solving an equation. So what I do is I take my formula y equals 3x plus 6. Now I'm going to substitute. I'm going to exchange y for 30. So now you have an equation with just one variable. Now we've substituted. This is no longer a rule. We need to find the value of x, and we're going to do it in exactly the same way you've been solving equations the last few lessons. What we're going to do is subtract 6 from both sides, and then divide each side by 3. and I get 8 equals x, or x equals 8. And then I'm done. So now let's look at another example. Please pause and copy this down if you need. So now we're going to use the formula F equals MA. I told you before why that does constitute a rule or formula. We're going to find the value of M if F equals 60 and A equals 4. So I take my equation F equals MA. So I'm told F is 60, so I'm going to exchange F for 60. Now, A is 4, so I'm going to change A to 4, but remember, MA means M times A, so this becomes M times 4. You know how to solve it from there. I just undo what's been done to M. I'm going to divide each side by 4, divide 4 times 4, cancel each other out. So I'm just left with 60 divided 4 is 15 is equal to M, and then I'm done. So let's look at this next one. So this is a little more difficult. We're told F is equal to M, and we want to find what A must be. So let's write our formula F equals MA, but F is equal to M. So I'm going to change this so I get M is equal to M times A. So now I need to find what would A be. Well, we have some intuition here. If I times M by A, I just get M. So think, what when you times it by itself doesn't change the number? So that, of course, is just A equals 1. But if we didn't know that, what we can actually do is divide each side by M. M's just an unknown number. As long as M does not equal 0, and we can assume here it doesn't equal 0, as long as it doesn't equal 0, we can divide each side by M. So M divide M is 1, and on the right-hand side, timesing by M, dividing by M cancel each other out. I'm just left with A equals 1. So that was a little more tricky because we had to divide by a pronumeral. All right, we're going to do one more example. Pause and copy this down if you need. So let's look at this example here. Area of a trapezium has the formula A, big A, equals H over 2 times little a plus b, where A is the area, H is the perpendicular height, and little a, little b are the two parallel sides. So we're told in this case the area is 50, two parallel sides are 6 centimeters and 4 centimeters, and we want to find H. So we know what a trapezium is and what it looks like. We did that in one of our previous topics. So it's a four-sided shape that has one pair of parallel sides. So little h is the perpendicular height, A and B are the parallel sides. So we're told we have one of these shapes where the area is 50, the two parallel sides are 4 centimeters and 6 centimeters, and we want to find this h, the perpendicular height. So this example shows why rules and formula are so important. They come up in heaps of areas, not just in maths, but also in science, economics, computer science, whatever. We need to be able to solve for unknown variables. Now, we did this a little bit in our measurement topic, but we just did easy topics where you just had one step, like where we had to find the length of a rectangle when we knew its area. Now we've got to actually go through, substitute, and solve an equation in order to find an unknown dimension. So what we're going to do is we're going to write our formula. Now this is a formula because it's an equation. You can see that there's an equal sign. It actually has four variables, big A, H, little b, four variables, and big A here is the subject of the equation. So that's why it's a rule or formula. So what we do when we're solving rules and formula, we substitute in everything we do know. So I know that big A is equal to 50, the area is 50, and I know the two parallel sides are 4 and 6. So I'm going to rub out the two parallel sides and replace them with 4 and 6. Of course, it doesn't matter which way around I write them, because 4 plus 6 and 6 plus 4 are the same thing. Now, I have an equation that has only one variable, only one pronumeral, so I can solve it exactly the same way that I've been solving equations before. Now, just to make it easy on myself, I'm going to write what's in the brackets as 10. 4 plus 6 is 10. So I got this. So to solve for h, I need to undo what's been done to h. So I divide it by 2 and then times by 10. So what I'm going to do is divide each side by 10. That undoes multiplying 10. So 50 divided by 10 is 5. I'm just left with h over 2 is equal to 5. That means h divided by 2, so I undo that by timesing each side by 2, and I get h equals 10. So that means that the perpendicular height of the trapezium is equal to 10 centimeters. And then we're done. So I know this was a bit harder. This formula is a tricky one, but I know you're really smart and have no trouble with it. All right, thank you so much for watching. This has been the luckiest maths teacher in the world. Have a great day.